We'll just get started. So, who am I? I inadvertently became one of the early webmasters. Actually, I was one of the first engineers at the marketing and editorial department of the first national commercial internet service provider back in 1993 in the United States. And Rupert Murdoch acquired us maybe about 2 months later, and about a year later, I moved down to New York City to help modernize the News Corporation sister companies like TV Guide, HarperCollins. I built the Die Hard with a Vengeance website a long, long, long time ago. And I had a chance to then go on to become the founding webmaster working for Lou Dobbs at CNN FN, the financial news network, and then had a chance to go work at Netscape, to go to the heart of the web in some ways at that point in time, back in 1996, a year after their IPO. And I was their webmaster, quite frankly. I had root on some of the servers, so that made me a webmaster. But I wrote the plugin finder. I helped manage the first web advertising program, put search on Netscape.com, and we had the highest trafficked website in the world, of course, at that time. I went on with a bunch of startups and start downs thereafter. I also had become the JavaScript and LDAP evangelist at Netscape for about a year there too, and worked at Silicon Graphics for about 6 years in operations, as well also as a webmaster and a lightweight architect there. And most recently, I worked at a WebSocket startup where I ran operations. We did the live streaming of all of the NASCAR races over WebSocket. That was pretty exciting. We did all that in Amazon, and that was great, architecting that infrastructure so that we could scale up and down, 50,000 users within a minute or two. It's pretty amazing. And then I worked at a cloud VPN company called Pertino, where we were ephemeral in about everything. We worked out of about 20 cloud providers when I finished. I was the DevOps manager there, and we were responsible for build and release, monitoring uptime of the service, and working across all the different disciplines to create tooling for a polyglot organization on the client side from between mobile and web and desktop, as well as on the back-end side being polyglot across different server technologies, runtimes, and so on. So the lesson learned there, even though we were a puppet shop, was that we always had to refactor and re-engineer all of our processes just as much as become cloud independent. So that's me in a nutshell. And if you want to learn more about me, it's my infrastructure as code blog is mlavi, which is my first initial last name, Mark Lavi, .github.io. And actually, we're going to be doing the slides right off of there from right now. I did a significant update today. So if you look for the DevOps Demystified blog entry at mlavi.github.io, you will see exactly what we're going to be presenting. And we'll drill down right here. And this is not the first time I've given this talk. I've given it a few times because DevOps requires evangelism everywhere. In fact, I probably give a digest version of this talk to almost every customer nearly every day in my current role at Nutanix. So let's start here with the slides. And quite frankly, let me see if this makes sense to everybody. Let's just get rid of that context. DevOps is a very mysterious term only because it doesn't have a universal definition. And this requires a little bit of context to understand why that is and why it's so compelling and why there's so much interest in it. So I'll try to give you an overview of the history and give you a cross-section view of just about some of the successes and some of the technologies involved with DevOps today, even though it's really only a mindset and such. But the term is less than 8 years old, and it is full of lots of questions because a lot of people seem to want the benefits of it, but they don't have the ability really to define it, and there's a reason for that. So we'll cover these topics today. And this is an overview of how we'll try to tackle this journey. I'll try to give you an overview and a definition of DevOps, and then put that in context of the history and the successes and challenges along the way. So it's not only, we'll try to put this in context of the journey that it takes to kind of understand and be competent at DevOps. that will also talk about the cultural side of things as well as the technical side of things. And that'll be the majority of this talk because truly what we've seen is a revolution in infrastructure, in operations, and in development. And all these things are feeding back on themselves and accelerating the change in all these things. So it's a very exciting time to be involved. And the output of the industry and the input from all of the practitioners is absolutely unprecedented. So we'll end up with where this all ends up and where we can go next. And I will give you your calls to action so that you can engage with the DevOps community. Okay, so let's get started. You already heard a little bit about who I am, and you can reach me here. This is my current contact information, including my mobile. I have a Twitter account where I blog about DevOps or tweet about DevOps or talk about interesting topics that are related to DevOps, but I'm not a social maven, so there's not a lot of updates there. Only high signal to noise quality there. But you already know about my GitHub blog, so you can find out more about me. You can find out a little bit more about my other thoughts on infrastructure as code. So let's try and talk about what is DevOps right now. And if you asked anybody around the world right now, they would give you a different definition. In fact, they might have trouble giving you a definition to begin with. And there's a reason for that. There is no universal definition. So even people on the same team in the same organization will give you different definitions of DevOps, even if they're DevOps practitioners, I'll bet. So if I asked you right now what it was, we know we would get different answers from everybody. And why? It's because DevOps ultimately is a culturally rendered term. It varies from organization and from practitioner to practitioner. So I'll give you a definition only because it helps advance every conversation. And because I've been a practitioner and inadvertently I figured out that I've been doing DevOps my entire life, my entire career, quite frankly, from being that early webmaster and being a web developer and trying to get the code out on the servers and figuring out how to get back the logs from 100 different web servers on the farm and distribute the right libraries and then make sure that we get the core dumps so that I can iterate to make a better design on my web development so that I can make a better interactive service back out to the customer and closing that loop. That's almost DevOps today, no different from anything else. So in doing so, in knowing this, I've been able to pull out more words out of my definition and make it more abstract, and it encounters and covers more of the nuances I see out there. So because DevOps is such a nuanced, culturally rendered term, this definition has been pretty abstract, and I'll explain why, but let's get down to it. DevOps is a process. And because it's a process, it's not a static thing. It's very dynamic. It's dynamically bound to the practices and the capabilities and the skill set of the people who practice it. So DevOps is a process. And just like security, it's also a process. It's a mindset. It's a journey of continuous improvement and pursuing the state of the art, and a journey of continuing that improvement and mastery. So DevOps is a process of removing friction between the developer and the customer. And if you think about this, delivering value to the customer is a business mission. And so this is how we can align DevOps and, quite frankly, the technical, engineering, operations, and development organizations all together to the business mission of delivering value. Now, whatever that value is, it doesn't matter. Whatever the business is or whatever the organization is, whether they're a nonprofit or for-profit or just a social media campaign, whatever the business is, it's just to deliver value to your customers effectively. So because of this, I'll give you some more nuances. It's not a process of delivering value one direction, only out to the customer. It's bidirectional. DevOps is a matter of figuring out what the value chain is between the developer and the customer, and figuring out every link in that chain, and then figuring out how to optimize the value of delivery in each of those chains. And so we can do analysis on any part. And you can do DevOps just on your own laptop. If you're trying to increase the instrumentation of your code, the deployability of your code, or even just the robustness and testability of your code, so that everybody else down the line, the QA teams or the operations teams, can consume that value and that increased delivery, well, then you're paying off dividends everywhere else down the pipeline for your doing DevOps just on your own laptop. You can consider yourself an internal customer, just as much as you can consider the testing and QA team a customer and the operations team a customer of any code. And so when we open this up even further, we'll realize that the developers are not only just the software developers, but they're also the testers and also the operators in our organizations as well. So there's a lot more rumination I can do on this, and I have blog entries which we can point to, but DevOps literally is a portmanteau, which is a combination of development and operations, because this is a hybrid between these two different disciplines, and all of the expertise implied and nuances implied are also part of this journey. So because you now have a definition, I want you to use that as a lens with which to evaluate anybody who uses the term. And you will see that there's a lot of hype out there in the industry, right? You know, this tool now does DevOps. My system administrators now carry pagers and they code up a little bit more of the automation. That's DevOps. Well, that's part of the answer. All of my developers now carry pagers and they care about the customers in production. Is that DevOps? Yeah, partially, absolutely. Again, you can now use this lens, this definition to evaluate anything. See whether or not Mark Lavi is giving you DevOps right now. If I help you accelerate the delivery of your value by understanding this block of knowledge, maybe I'm doing DevOps for you. So again, more ruminations if you want to learn more, of course. And all these slides are on my blog already. As you know, we're consuming this directly. So let's talk about the history of DevOps, and that'll give us even more perspective on where we're going. And there are many other folklores, and I definitely encourage you to go see from some of the primary resources. The benefit of this all starting in, the term starting in 2009 is that a lot of this primary authored materials are available on the web, although we see a lot of anthropology happening where things get scraped away, and archive.org is definitely your friend in that case. But going back to 2009, just almost 8 years ago now, just a little bit more than 7 years ago, there was an Agile system administration Google group where a couple people started discussing what it took to basically make infrastructure go faster, go agile. And it's because these folks really cared about not just the code and not just the infrastructure, but the combination of those things. And so those are the very seeds of DevOps. And it's literally these people that are the founders of the DevOps movement. So going on to May in 2009, there was the Velocity Conference in San Jose. And Andrew Clay Schaefer presented an Agile infrastructure presentation. And in his slides, you will see him mention development and operations on the same slide. And he was talking about the barrier and the friction between these two teams, how they almost have an adversarial relationship because the developers code up stuff, the operations team is a completely different world. They never really talk to each other. The developers just throw things over the wall to the operators, and the operators deploy it. And when things break, they get upset with the developers, right? So this is an adversarial relationship, and this is why we have so much friction in delivering value. So at that very same conference, we have John Allspaw and Paul Hammond representing Flickr, explained how they do 10 or more deployments per day, development and operations cooperation at Flickr. And this is at the very same conference. Absolutely seminal moments when people are starting to talk about these things and how they have started to merge and make the gap between one side of the house and the other side of the house start to work cooperatively. So back to that Agile system administration group, Patrick Dubois posts his proposal for a couple of different development and operations and Agile system administrative type talks. And he says, I want to go and I'll be at this conference in Chicago. And he actually didn't get any of his talks accepted. And then he tried to find Andrew Schaefer, who actually I think presented the Agile infrastructure talk again. And if not, I think there was an open spaces, but nevertheless, nobody showed up. So Patrick found out and sought out Andrew. And this discussion started to happen between the two. And that's where the term DevOps was born, literally at this conference. And within a month or two, we see Patrick uh, proposing the first DevOps days in Belgium, and this is the beginning of a physical community and a movement, literally the inception of it. And you can trace back to all this back to the Agile Systems Administrative Group, and I've linked to all these things. So what happened between 2009 and 2013? Well, this movement started to happen, and it grew very slowly, literally DevOps days by DevOps days, and by conference, and people starting to talk. And I would say another seminal moment really didn't happen until 2013, where the Phoenix Project, a book by Gene Kim and other authors, really illustrated the business impact of DevOps. And at a traditional manufacturing company where you wouldn't expect that software or IT would actually be a critical juncture of running the business, but this was the whole point of the Phoenix Project. It's an absolutely riveting read and a train wreck and redemption, and it made me cry. I'm exaggerating a little bit, but it was an incredible book, and this really woke up a lot of people also when it started to sell well and explained the term DevOps. The next year, we saw Gene work with other people to start to create the State of DevOps report. And the results that they started to announce was that high-performing IT organizations are twice as likely to exceed their profitability, market share, and productivity goals. In essence, DevOps is a transformational process that helps the business achieve its value. And so in the most recent year, last year, the State of DevOps report gave significant metrics now with over 4,600 survey participants showing that we get 200 times better deployments or faster deployments than the slower performers in the category. Just inside of the people who responded back to the State of the DevOps report in that survey, they found that the leading or the fast performers were over 2,000 times faster in implementing features, 24 times faster in covering from failures, and had 3 times less, or 1/3 the amount of failure rates. So this is absolutely amazing that we finally have some metrics behind DevOps, and more people have stood up and started to take notice of it. But because there's no central definition, there's no center of the DevOps movement, it's really headquartered inside of each of us as our practitioners, as a community. It's a mysterious worldwide movement, but also a buzzword in a dynamic community. But ultimately, I would say, and many of us would argue, that it's a rediscovery of the law of the lean processes, the Agile Manifesto, which is a programming coding manifesto, but applied now to infrastructure and our processes. And it feeds back to software, which we'll see a little bit later. And really, it is the software discipline applied to refactoring our infrastructure and operations. And I'll explain why in just another moment. But it has the corresponding follow-on effect of DevOps has now implied and worked and changed application architectures, because now they are being refactored to incorporate operations. And ultimately, we are just rediscovering how manufacturing theory can be applied to technical work when we hear about terms like Kanban and so on. So what does DevOps success look like? And what are the challenges that we see, and that I see almost every time I talk to a customer out there? Well, success is really a mixture of technology and cultural transformation in order to gain this business agility. And this mixture between technology and culture sometimes can be heavily tilted only towards culture. It turns out tooling and technology, those are usually easier parts of the equation and easier parts to figure out once you have alignment inside your organization for what you want to accomplish and you're open to trying to do these changes and do them in an agile sort of way so that it's not a huge, big risk waterfall, 1 year long-term project. Get to just some small successes on a small time frame and build from there. So the corresponding challenges we see to the success, for technology success, we see technology fragmentation as the challenge. And broadly, we see ecosystems that are in development of different tools and platforms are different from the ecosystems that the testing and development organizations are using, which is different from the operations and IT organizations are using. So there's so many tools, so many platforms, so many APIs. They're all iterating at different rates, and sometimes as simple as quickly as version by version or even quarter by quarter. So this fragmentation and complexity is just growing like mad, and everybody tries to address this with very fragile point-to-point integrations at their first step. And as a result, unless these integrations are really built into platforms or even treated as first-class citizens as the software code base itself, we see them even representing their own point of friction. And not only that, the cultural side of things has a challenge as well. And there are many facets of it, but ultimately it comes down to people. And here's where I'll give the most cautionary tale of it. I think it's a mistake for organizations to hire DevOps people. And that's a very contentious statement, and I'll tell you why. First off, DevOps people are amazing. They are the catalyst for change, and they are highly sought after because they're so valuable. They can map the value chain from the developer all the way out to the customer, and they can integrate things and they can code. And it's hard to find these unicorns. They're expensive. They're very difficult to keep only because if the culture side of the equation of DevOps success doesn't happen in the organization, then they will figure out that the DevOps team, however small or big they are, is a bottleneck for all of the business to deliver its value. In other words, they will see all the technical and all of the cultural debt inside the organization and see that they are being treated, the DevOps team is being treated as a bottleneck. And as a bottleneck, that means that they have to scale through headcount, which is a huge mistake. It's an unsustainable business practice to try to scale anything just through headcount or just through people. And if the culture doesn't change where they help improve this problem at the organization, the DevOps people see the writing on the wall and they leave. So I frequently get asked, Mark, how do I hire DevOps people, or how do I keep DevOps people, or how do I staff for DevOps people? And ultimately my answer, no matter what, is you don't. And so there's a corollary to that. That seems disingenuous and counterintuitive. So here's the corollary. The journey to DevOps means that we are all DevOps, and this means there is a continual evolution in every organization. It's a cultural change to reduce the silos between development, tests, and operations so that we distribute the DevOps mindset and the DevOps value across development, across test and QA, and across operations and IT. We are all DevOps. This means there is no one DevOps team. Everybody might be a DevOps person on their team, and they share in the responsibility to deliver the value back to the customer. This is the business mission. So development and test and operations share in developing the value, testing the value, and delivering the value. And they share in the responsibility in making that go quickly if we're truly adopting the DevOps mindset. So that's how we remove the friction between development and test, and from test to operations. So to that end, that means that we're talking about development and operations working together, including testing. It's not development versus test versus operations, which is the traditional way most organizations happen. And let me give you an example. Let me give you, usually product marketing asks for a brand new feature. They talk to their press release folks and their marketing folks, and they say, all right, it's going to be delivered in a quarter. We need to announce that for the quarterly results. You need to set up all the marketing campaigns and buy the advertising a few months in advance. It's going to be delivered next quarter, this brand new feature, this shiny new feature that will make our business greater and better for our customers. And this is the way a lot of people organize things, and there's nothing wrong with that. However, let's take a look at what really ends up happening in almost every software organization in the world. Well, the developers start to create that shiny new feature. They create the unit testing around it so that they make sure that functionality works, and they make sure that it builds. They commit it to source control, and they say, my job is done. They clap their hands, and they hand it off to QA. QA's problem now. QA and test folks have to test this brand new functionality, but increasingly they have to test it on more platforms. Remember the fragmentation problem I showed earlier? So because they have more platforms, more mobile platforms, more web browsers, and so on, they are already drowning in that complexity. And not only that, they have to regress all the old functionality on these new platforms, plus test the shiny new feature. So they are drowning in technical debt. And unless they're automating their way out of this pit, they will never be able to complete their testing by the end of the quarter. And so they ultimately are time boxed and they have to hand it off to operations to make sure it gets delivered in time. So it's now operations problem. Operations does all the change controls. The IT folks, manage everything. They upgrade things in place. They do the database schema changes. They do the partial outages or the rolling partial outages so that they get this brand new shiny feature out and delivered to customers. But what happens almost instantly? Customer support and sales starts calling them because the customers are calling them and complaining. You know what? I'd like that brand new feature, but all of a sudden your website or your service is slower. So what turns out to have happened? Well, maybe we shipped a brand new feature, but we've also shipped a performance defect where 100 milliseconds we've gone slower on the load balancing APIs or something like that. So if we ship a new feature and we also ship a performance defect, have we increased the value to our customer? Arguably no, especially if they don't get to the shiny new feature to begin with. So this means operations doesn't trust test and QA to do the right job to make sure that they get a performant product out to customers. And likewise, QA says to development, you don't know how to develop for the customer in production. Why did you just test on your own laptop? And so at the end of the day, this becomes an adversarial relationship. Operations doesn't trust QA, QA doesn't trust development, and now we are a risk-adverse organization, which slows things down. We add more processes and more procedures and more gut checks just to be secure and try to manage risk. But what we need to do with the DevOps mindset and a DevOps lens is to invert this behavior so that we reduce the silos between these teams. So what does that look like? That looks like relentless iteration towards automation to yield distributed work. We need to democratize the domain expertise of development. Anybody should be able to build the latest bit of code. Everybody should be able to test the latest bit of code after it's built. And everybody should be able to deploy that code after it's tested in an automated way. So this means that we are democratizing the brilliance of development and test and operations so that developers can push out a hotfix to the customer within seconds, within minutes, within hours, and it can be automatically tested to have a minimum viable amount of software quality. And so the organization works towards this together. The testers have to create an automation and platform that they have to help operate all the automated tests that they work with the developers to create. Likewise, the operations team needs to give tools to the developers and the testers to build these platforms and deploy on these platforms, and so on. And what this means is that operations starts doing development for better tooling. Testing makes more tooling and operations so that they can automate the testing. And developers work harder to make their code instrumentable and deployable so that they can be tested automatically and deployed automatically. So this is how we finally make everybody's work repeatable, auditable, and even automatable. Because we finally make it push-button operations to build, test, and deploy, this means we can start to tie together the entire value chain from the developer all the way out to the customer. And this is how we do continuous integration, continuous delivery, and continuous deployment. The only difference between these things is that continuous integration just helps bring together all the latest build and make sure that it builds and it stands up. But if we do continuous, we take it to a next step where we actually do a little bit of testing on it in an integrated way so that we see that this brand new artifact and this brand new shiny piece of code stands up with the whole medley of services. Well, then we can automatically deliver that, say, to staging or to development stacks or to QA. And then ultimately, if we can automate all the testing to a certain level of guaranteed quality, well, then we can deploy it all the way out to customers in production, and that's continuous deployment. So this means we finally get the agility that the organization wants, because now we can have it where a developer finishes coding something and it can be automatically delivered out to the customer. This agility means that also we get to reproduce the ability to stand up any of these test stacks or development stacks or staging stacks or even our production environments at a push-button operation. This means that everything is ephemeral, everything is temporary. We have no longer a single point of failure. And what this also means is that if there are any problems, well, because we are constantly delivering value, this means that the change since the last delivery value is very small. This means that every error is a small failure. And it can be fixed very quickly because we already have the ability to revert things in our operations, in our test, in our development. And so even if we don't revert things, we can fix it very quickly too by restoring an old version and so on. So what this means is that we've gone to the point of agility and ephemeral everything. We have an attitude where it doesn't matter how fast we move things forward because we're trying to minimize the risk by doing small little steps all the time, and we're constantly increasing the flow of our value. So it's not enough just to deliver this value out to the end user and to our customers. We also have to close the loop for health and value measurements because remember, we talked about shipping that shiny new feature, but also having a performance defect also shipped it out when the website or the service or the load balancer went 100 milliseconds slower. So the only way we do this is by putting instrumentation inside of our development, inside our builds, inside our tests, and inside our deployments. So that looks like monitoring logs and metrics for all the key performance indicators of what it takes to build something successfully, test something successfully, and deploy something successfully. What this means is that all the systems that we use should leverage those domain-based KPIs, but ultimately we want to aggregate all these things up to business metrics and key performance metrics. So do I have more customers signing up this hour than last hour? These are business key performance metrics, but they should be a roll-up and tied to all the other KPIs that we get from the other parts of the organization. So this means we have continuous feedback. We are closing the loop on everything that we deliver, and we can answer the question, what is the health of our applications, our APIs, and our KPMs? And we can also measure whether or not we're increasing the velocity of our development, of our testing, and of our deployments. And we can also measure if we're increasing the value in each of these pipelines, because we're tying it all together and we're measuring it all. And ultimately, this means that the developers care about the customers in production just as much as the operations team does and the QA and test development team does. And we all evolve into sharing responsibility to the customer, and we all evolve towards caring about the entire service delivery. And this is how we get to what measured improves. So that's the cultural side of things and the overview of what the nirvana is for us. There's many different technologies involved in doing this. And you don't have to adopt any one of these or all of these together, but this is what DevOps has started to be an embracing or an umbrella for a lot of these technologies. And they happen on the development side, they happen on the testing side, and they happen on the operations side. And all these things, because they share in responsibility, are feeding back on each other and increasing the value of each of these tools and platforms and APIs. So let's talk about these things. At the end of the day, as long as we have now push-button infrastructure anywhere, we can now codify how we deploy these things because we have an API on our infrastructure. And this has led to the rise of immutable infrastructure, new architectural application designs, and microservices is an exemplar of it. And it is where the application really cares about the APIs and how it's operated. And it's led us to also look at infrastructure in a completely different way. And the pets versus cattle analogy is what comes to mind here. Ultimately, we see that infrastructure as code is really just another software development engineering methodology. And we get to testing and building and deploying our infrastructure and our applications all together. And this has got a lot of different implications on how we look at orchestration and rolling out and the infrastructure models we have. So let's just drill down on that top level overview. So it's no secret that every load balancer, every tool, every SAN, every switch in the network, everything now has an API. And quite frankly, we already know the web has one, so they're RESTful APIs. These are web interfaces, and they exist everywhere now on everything. And people are even retrofitting old tools to have RESTful APIs so that they can be orchestrated and instrumented and used with everything else that is out there. So this means that now we can use these APIs and we can codify any operation invoking those APIs. And this is what it takes to stand up infrastructure in the cloud, in the data center, with containers, with anything. It doesn't matter whether they're on the public or private cloud because now they all have APIs. And we can deploy against these things in a hybrid fashion between different form factors. Bare metal can have APIs. So can public and private cloud, and so can containers. It doesn't matter if it's a VM or bare metal or container, what the form factor is or what the provider is, whether it's on-prem or off-prem, it doesn't matter anymore. We have APIs everywhere and we can codify our infrastructure. So again, even our development tools, our testing tools are getting RESTful APIs, and we're making that work repeatable and auditable. And so this means, again, because we can stand things up in the cloud easily, we can rip them down, this means everything is ephemeral and agile. So the corollary of being able to have these RESTful APIs is now we can codify things. And this is truly how we apply software engineering practices to our infrastructure. And again, these slides are going to be available. So if you want to, you don't have to, you can grab them later on for screen grabs. You can version control everything now, even our databases, and we can put them under change management and so on. And this has given rise to a whole field of configuration management, a whole industry, and the exemplars there are Puppet, Chef, Salt, and Ansible. Even operating systems have started adding things in like Canonical's Juju on Ubuntu. And CF Engine is kind of the granddaddy of all these things. And these are just configuration management systems that are, if you want to think of them, they are kind of, whenever you stood up a brand new server, you had to install everything by hand. Well, you could take the next step of that by putting shell scripting around it or PowerShelling, what it would take to install a new thing, configure it, and add the data to it, and so on. So configuration management is the ultimate realization of this dream of how to automate installing any facility on top of an operating system or on top of a resource. And so this is literally how we satisfy the mantra that we need to deploy all of the things with configuration management. I need to deploy a web server, a cache in front of it, a load balancer in front of the cache, an application service tier, and I also need to configure a database. All of these things, each of these individual things can be brought up with configuration management right now. And they can even be made, our configuration management code or runbooks or playbooks or manifests, they can even work across different operating systems with different versions of different facilities. And so configuration management is how we've kind of made code deploy infrastructure and applications together. And so ultimately, this is all done by running configuration management on each of the different servers or resources at runtime, and literally we build the infrastructure and the application and the configuration all together right there on the server after it comes up. So this is a runtime operation. And so this means that, yeah, this is how we get to ephemeral stacks of all the different applications and the environments to do push button development, push button staging, push button QA, push button production, in essence. But the problem is that now that we have the ability to stand up a database and a web server and a cache and a load balancer and all these individual pieces, we need to tie it all together into a medley. And that is a full stack or a full application. And this requires orchestration between all these things to make them work together. And it's a challenge. And different configuration management systems do this, or do not do it at all, or do it poorly. So there's a challenge there, something to be aware of, because once you bring up a database, well, then that's great. You still need to make everything else find it and use it. So the next step towards infrastructure as code is that now we've worked on immutable infrastructure, and I'll go a little bit deeper on this in a moment. The idea is that we now have the ability to we need to no longer have individual handcrafted servers that we hand installed and hand maintain anymore. And each of them, we treat them as a special snowflake or as a bespoke system that's handcrafted and hand maintained. This really represents friction in today's viewpoint. Because this is the way infrastructure used to be built by the system administrators or the priests on high, and they didn't give you the keys to build anything. You had to get them to do everything on their behalf, and they performed their dark magic for you. And so you were beholden to IT or operations or the infrastructure teams in order to get a server for you even to get an application installed thereafter. So today, that's automation friction, and that is technical debt inside your organization, and you need to file bugs against the IT organization and the infrastructure teams to say, I need to be able to use configuration management to deploy my infrastructure. And once we get to this point, we can start to make our infrastructure immutable, and I'll drill down a little bit more about that. But again, we're trying to democratize the expertise inside of infrastructure teams and so on to make their work repeatable and auditable with configuration management. And so the next step after we do this automation of deployments is we also need to get to lifecycle operations. What does it take to scale it up and scale it down appropriately, do forensics on it, back it up, upgrade it in place, and so on. And so we can even put code on top of how to do operations. And this is where we'll get to behavior and test-driven operations, and that's an emerging field. And if you're interested in that, please seek me out afterwards. So let's talk about immutable infrastructure, since I've highlighted it a little bit before. If you think about our servers as something that we mutate with configuration management at runtime, because we write, the configuration, we install the new services, and we get them running, and they write their logs out onto the file system, and we need to collect those things back in order to see how the entire web server farm or web caching farm or any application tier works. Well, let's change that. Let's think about now a server as being a read-only file system. This means that we don't have logs anymore, at least not logs that ever touch disk. And we don't change the configuration anymore because we can't write to disk anymore. This means that we can only pre-instantiate the entire file system with all of the application on it, but not the configuration. We want to give the configuration as a runtime environment variable, or dynamically give it to this brand new system that stands up and has already the infrastructure defined on it. I'm a web server and so on. And so this is truly where we think about our infrastructure as being built. We even have build systems, and we can use configuration management such as Chef or Puppet or Salt at build time to build a whole new server and snap it off and crystallize it onto disk, make it read-only, and now we can put it in a repository for distribution. And this is where we literally get to not a build or a code artifact, but an infrastructure artifact. And this is really ideal for non-persistent application tiers, because now we don't write to disk anymore. We ship all of our logs, our metrics, and our instrumentation off the box. We get our runtime configuration for where the database is or where to connect into other things just through runtime and variables, because the configuration is now dynamic. And this is the way we can now, we don't have to have a monolithic big database or a big web server anymore. We can put multiple of these things behind a load balancer, and all we have to do is measure their health. Did they come up appropriately? Now let's roll them into the load balancer. And so this means that it's very easy to make changes and change your application rollouts by baking it into an immutable infrastructure artifact and rolling it out. And so this is really an amazing revelatory thing, and it doesn't have to happen it can happen anywhere now. It can happen on bare metal, it can happen on virtual machines, and quite frankly, most people are looking at it only from containers, and we'll get there next. But the industry is also trying to address persistence across immutable infrastructure because, well, we need to do remote file systems that aren't the same thing as the infrastructure file system. And so that's one way to deal with it. But more often than not, people are working with cloud-native applications where they are already distributed and they have no single point of failure and they cluster their state. So we can drill down on that later on if there are questions. But at the end of the day, because there's no difference between the infrastructure artifact that you stand up on your laptop, in development, in staging or production or in test, because they're all the same, all that changes is their runtime configuration through environment variables. This means that it is the same artifact on your laptop as in production, and this closes the risk and the gap between everything that happens on your laptop and what happens out there for the customers in production. So immutable infrastructure is a huge concept, and it has led to another thing. Just as we build infrastructure now, we also are looking let's talk about microservices. Just as we build our infrastructure, we used to build big, huge monolithic code bases. Everything was just one code base. We built it and we deployed it. And now we could even build that into our immutable infrastructure, and that's how we can deploy our things. But as code bases get larger, as more and more teams work together and also work on different pieces of that code base, it has been decomposed in multiple different ways. Our infrastructure has decomposed into multiple things, right? Three-tiered applications, web in the front, application in the middle, persistence in the back. Well, same things are starting to happen inside of the application architectures themselves. And so microservices adopt the same thing as everything else as we talked about, our agile infrastructure. They adopt RESTful APIs. And Amazon is the absolute manifesto and absolute touch point in this revelatory way of looking at how to write and deploy applications as small services that are independent pieces of functionality with only a public API. As a result, this means each team and each feature can be shipped and tested and deployed independently of all the others. All they need to do is be tested together, and all they have to do is make sure that they honor their APIs. And so this means that now we have a new delivery model of applications on top of our infrastructure. And so this means there's a different set of challenges for testing and monitoring, but ultimately, this is how we can now have the infrastructure decomposed to multiple services and the application itself decomposed to multiple services. And microservices is really this architectural model. And this means that each team, each component, each artifact, each feature can ship on its own schedule, deploy on its own schedule, and test on its own schedule. And this means, again, we're delivering more value quickly to the organization and to our customers. So another thing that I started to touch on, especially during immutable infrastructure and our agile infrastructure, is the pets versus cattle analogy. And let me drill down on this right now. So because we have the cloud, because we have APIs to spin up infrastructure right now, and because that infrastructure can stand up in minutes or seconds, because of this, we don't care about long-lived servers anymore. So this means that we need to describe the way we looked at infrastructure, and the way we looked at it were pets. I worked at Silicon Graphics, and we had an IRIX O2 system that was a refrigerator-sized server. It had multiple CPUs, multiple disks, and things like that, and it was our Oracle database for the enterprise customer resource system, management system. It was our ERP system, excuse me. It was the lifeblood of the business. All of the sales and other things like that were there. It was a mission-critical server, and the team was so proud of the system administrators. We were so proud that we had this up for 12 years of uptime, but we had to do a data center move. And all the system administrators were upset because we would never see that amount of uptime again when we moved it to the new data center. We'd start over that clock. Well, that's 12 years of us caring for this one server because it was mission critical. We replaced the CPUs whenever there was a problem. We hot swapped it. We'd hot swap power supplies. We'd hot swap failed disks. We did backups of this server every day, if not multiple times a day. That's 12 years of backups, 12 years of care and feeding. We named this individual server, since it was so mission critical, was Constellation 22 or something like that. We described everything, and we had an emotional attachment to it. And this is why we call it a pet, because we gave it human characteristics. We attached emotional characteristics to this thing, and we were concerned about when it moved to the new data center, would it come up fine? Well, that's ridiculous. Now that we can spin up another server in any data center with just a few seconds, we really look at things now as cattle. We don't want to have pets anymore, because that pet was a single point of failure, and it was very costly to fix it. We tried to fix it all the time, and that was 12 years of monitoring it, backing it up, maintaining it. That's many more times worth what that server was, or the software was on it, or even the data on it. So cattle is the contrast. We can spin up a whole fleet of database servers, and if any of them get sick, well, we don't take it to the vet, we don't fix it, we shoot it in the head, and we replace it with a brand new one because we can spin up another one in a couple of seconds. Only if we want to fix something or do forensics or do remediation on it to get to the root cause of a failure will we do that. But in the meantime, we're spinning up a whole fleet, a whole management, a farm of different servers that satisfy whatever our uptime needs to be of the application. And we have a set of cattle, not a set of pets, is how we look at things. And so This goes back to immutable infrastructure and everything else. We don't care about fixing any one server anymore. We replace it and we keep up our service level agreements. So this is one way to now look at architecture. Do we enable pet operations? Do we care about changing one virtual machine at a time, or one server at a time, or one container at a time? Or do we care about maintaining a fleet of servers or containers or virtual machines in order to keep an application uptime for its application tier and its architecture? And so this makes everybody look at architecture, at applications, at infrastructure, and at operations, and even at data centers in a completely different manner. If we treat everything as being one data center, well, that's a pet data center. So please use this lens with which to evaluate things. So it even goes further when we talk about containers. Containers, if you're not aware, are, and I'm sure most of you are, but I'll just do this really quickly. Containers are really a very lightweight way to do almost the same job as a virtual machine. However, you don't have any of the overhead of the operating system, and you don't have overhead of the hypervisor. Instead, you have the container engine, but that even can be minimized inside the kernel. So this means that we have a smaller infrastructure image artifact, and we have quicker time to stand up a container and also bring down a container on the order of sub-second. So when we contrast this to spinning up a bare metal machine, which is minutes, or even a VM, which is still potentially minutes in the cloud, containers are disruptively good, they are agile, and they are agile infrastructure. So this makes them even more ideal for doing continuous delivery of immutable infrastructure artifacts, and ideal to match with microservices. And that's how we've tied together all these things that I've laid up to this point. And again, as you know, the benefit of immutable infrastructure is that there's minimal difference between your laptop and production, and milliseconds to try to do things. So you can test things in a very rapid cycle, and this speeds up everything, even just testing on your own laptop. And because we can spin them up and spin them down so much more fast, or so much more quickly, we really ascribe the notion of bacteria, because this is the life cycle of just seconds for these things. So that's how we go on this continuum of ephemerality, from pets, which are long-lived infrastructure, to cattle, which is a fleet of shorter-lived, to bacteria, which are containers, which really can only stand up for seconds, maybe only on a QA instance or build, or even just on your laptop. Now, people do containers that are long-lived in production, but they don't have to. And so the reason for that is because there are still a lot of production challenges out there. Orchestration of all of these containers and doing the health and networking and persistence and dynamic configuration. A lot of these things are addressed many different ways, and most of them are solved by adopting a container platform as a service. But all of these things also lock you into their models of deployment and configuration and so on. So that's why not everybody puts containers out in production right now. But that's changing every day. So let's talk about this. Now that we can really build things really easily, then deploy things really easily, this means that we need to start to take a software methodology viewpoint on how we actually build and test and deploy our architecture. And if you really get into software engineering, you understand that really we have to start doing test-driven development. And this means we build our tests first, then we build our infrastructure and make sure that they comply to our tests, and then we deploy those things. And so again, we're minimizing the differences between production and development only because everything that we do on our laptop to test and build and deploy is the identical amount of tools that we should use for production. And this means our infrastructure and our tooling of our infrastructure is the same thing. This means the way you troubleshoot something on your laptop is the same way you troubleshoot something out in production. And again, we're minimizing the friction between anybody, increasing the value to the customer. So this is where we go from very individual. Developers used to look at things as, I only have my piece of functionality and I only test my little piece of functionality, and I don't really care about the integration of everything else. But now that we have container and immutable infrastructure artifacts, we can stand up all these things potentially on the same laptop, and we can test fully application integrated systems instead of mock systems. So this goes even further when we start to go test driven on our operations and our infrastructure. this becomes the test-driven mantra is we start to build our test, and then we build our code or our infrastructure, and we test it, and every time it fails, it's red. And we keep working on it until our test and our infrastructure meets some minimum viable amount of functionality. It doesn't even have to be anything more than just stubbed out. And then it finally goes green. And now you start to build more value into your testing and more value into your application code and correspondingly into your infrastructure. And that's how you go back to refactoring it to add this functionality. It goes red until you make the test work again and the functionality work again. It goes back to green, and you keep doing this. And this is a very tight, agile development loop. And this is what we need to do to go forward with our infrastructure ultimately, and our operations and our governance. So the idea is that we are testing and building and deploying on our laptop. And again, this leads back into just another repeat of that test and build and deploy pattern when we get to continuous integration and delivery. So it's not enough just to do all of these things for the individual pieces. And we talked about orchestration to kind of bring the medley of all the different infrastructure components together into the big application or the full stack or the full environment. And so this really gets to the point of what does it take not just to orchestrate things, but to deal with the life cycle of our instantiated elements. And even though we might shorten their lifetimes when we go to containers, we still have coordination and cadence and operations between all the different pieces. And so this is where infrastructure orchestration is still very much a difficult part and a necessary part of our automation. And so, again, trying to match out all of the infrastructure artifacts in a manifest, all the operations and dependencies between these things, and then how to do them in the right order is difficult. So what happens is we have a whole bunch of new techniques that you may already be aware of or may have already adopted, but we have now automation around these things. And so when we get to continuous deployment of out to production or even just delivery to staging or testing or development areas, well, we have different strategies. We have kind of the completely atomic and parallel population. I have a brand new version of infrastructure. I have a brand new version of code. I bring up a parallel population and I bring it into a load balancer and I cycle out the old population and then I destroy the old population. Or I test it, and if it doesn't work, I destroy the new population and bring back the old population into the load balancer. This is a completely parallel between the old and new populations, and we call this blue or green deployments or red-black deployments. But as you can figure out, if I have a huge application tier of 100 servers, well, this means all of a sudden I burst up to double the population of 200 servers. And to coordinate pulling them all in and out of the load balancer, well, that's not going to happen in 1 second, unfortunately. So we're increasingly seeing people go towards rolling or canary deployments, where they basically incrementally upgrade one of the servers behind the load balancer. They take it out, they upgrade it, they test it, and if it's good, maybe they even let it stay there for an hour and see whether or not there are any problems before they bring it back into the load balancer. Or they bring it into the load balancer and they watch it again for an hour. Does it behave differently from the rest of the fleet? And if so, then we will revert it. And if it does pass all those health metrics and we're happy with it and we think it's soaked enough, well, let's go on to the next one and we keep rolling forward. And this might be done with a percentage of the servers of the fleet behind the load balancer, maybe 5% or 10% or 1% or server by server. And therefore you have rolling upgrades. But what this requires is that you test and measure your operations and that those upgrades and those deployments go forward as you want. And again, this is how you close the loop so that you can continuously deliver upgrades, but not just as an atomic way, but in a rolling sort of way so that you can revert back in case there are problems. And if you remember, this is also how we kind of do that fail fast and fix fast methodology as well. So this means that there's a whole bunch of new challenges when we start to really have the flow of different applications and different infrastructures and different stages and different versions of everything all flowing together now, potentially all independently. Orchestration becomes even harder, but even more essential in order to get all these things done. And we see impact back on the architecture of the application itself. Now we need to manage the APIs between different versions. And this is not something that everybody figures out on the first day. We've also seen new systems and methodologies happen where we actually light functionality. We will ship functionality out there, but not actually activate it until we dynamically turn it on or off. So that way we don't even have to redeploy things. We can turn functionality on and off. And we call these feature flags or featured lightness. And in some ways, people say this means we don't need to have development or staging anymore. We just ship everything and we turn it on and off. And this is completely a new methodology and a new way of thinking about applications and testing and functionality. And again, metrics is essential to close that loop to make sure that you have everything done properly. And then we even see fragmentation of the DevOps movement towards rugged DevOps so that things can fail a lot more. Security DevOps and network DevOps and so on. We see infrastructure and orchestration just on switches and on SANs, on networking and so on, and just even security. And so all of these things feed up into the big DevOps umbrella, but they require new orchestration and new ways to flow into the bigger model. So those models look like everything that we used to have, but now more on a global context. It goes without saying now that we can no longer have a single point of failure, no longer monolithic architectures or monolithic applications or monolithic infrastructure anymore. We need to load balance everything in a local context in a data center or in a cloud or in availability region zone. And once we get past that of having each of these immutable artifacts or even these mutable servers that we do through configuration management behind a load balancer, we ultimately want to get to the point where we get to higher utilization by clustering everything together, and we distribute multiple workloads on those clusters. So we get higher utilization. And containers are an ideal way of doing this. We see this all over the place. But then it's not even enough just to have this in each data center. We also need to do global load balancing so that we get global redundancy or even active ability to increase the performance by chasing our customers around the globe by having a local data center to them. And now we have to have active applications, persistence of state, and monitoring and deployability. So it gets more and more complex, but this is the way the world is looking at things and has been looking at things, but it's been a proprietary domain of the largest engineering organizations, and it's filtering all the way down through DevOps to all of us now. It's not even enough just to automate all of our infrastructure operations, making them instrumentable and even testable. But once we've done that, we also have the ability to we delegate these things back to anybody. Anybody can do operations. Anybody can do an upgrade. Anybody can do a test. Anybody can do a deployment. And so we're starting to put APIs on top of our operations. And we call this operations as code, as I already alluded to earlier. And chat ops, where we can literally deploy a brand new stack or even upgrade a stack or upgrade a development environment or change a feature flag through API manipulation, is happening just in chat rooms. And again, this is another form of the democratization of all of our operations and agile operations. So again, we don't have to wait for IT or anybody else to get things done. Anybody can deliver value to the customer through multiple interfaces, through multiple APIs. And if we can democratize those APIs to be as simple as possible, so much the better, so that we have a single pane of glass and we don't have to even leave our communication mechanisms in order to execute code, test, and operations. So, great. That's a huge world of accomplishment if we can accomplish all that inside of the technical domain. But we want to make this value delivered throughout the rest of the business. Now that we help the business agilely deliver value, now we can help start to commoditize all of the other friction inside the organization by applying this same DevOps lens to everything. All of our customers, all of the business constituents, all the application owners, and all the other process owners inside the organization, and all the other system owners like HR systems, inventory systems, every system and process inside the organization is ripe for automation these days. And this is where DevOps escapes out of the technology domain and we get to accomplish business agility. And so the first inroads of this that we're starting to see is compliance at velocity. And here's a link here. And security testing so that we always make sure that our infrastructure is secured based upon all of the current vulnerabilities and so on like that. Automated security and compliance is the next step to make sure that the business is running appropriately, and we're going to just go deeper and deeper. So that's the epilogue for where we can go next. So I'll thank you right now. We've done just a little bit over an hour. We've covered a huge amount of ground, and I've tried to start to interrelate them, and I know I can do a better job. But this really represents the state of the art of trying to put an umbrella around all of this value and all the processes that are involved and everything that's implied. So reach out to me any which way you want. You can grab these slides right now. There's the URL. I would like you to evangelize them to all of your colleagues so that you can get DevOps working better or get it started inside your organization. But even more so, come and find us. Join your local DevOps community. We are all the way around the world. And if you remember Patrick and Andrew meeting together, they created the first DevOps days. And that has started from day one all the way to today, and it's expanded throughout the world in more and more cities each and every year. So you can go find your community at DevOps Days. You can search at meetups just for local DevOps queries right here. It's really simple to find anybody around your organization. So let's find DevOps within, wherever I am right now, and so on, right? And you find multiple instances. So you can find your colleagues and our community everywhere. And even more so, you can see the history of how many conferences are going on as we've tried to spread this word and this mission and share in our expertise and become a communal fountain of knowledge, of practices, of technologies, of culture changes, and of problems, and we crowdsource our problems. Come and join us. So, thank you very much. I'll open it up to any questions. I appreciate all of your time.